I'm going to show you 25 lines of Python code which solve it in 50 milliseconds using a math formula. Let's dive in. We are given a dig plan for a lava lagoon. How many cubic meters of lava could it hold? The digger starts in a 1 meter cube hole in the ground. They then dig the specified number of meters up, down, left, or right, clearing full 1 meter cubes as they go. The directions are given as seen from above, so if up were north, then right would be east, and so on. Each trench is also listed with the color that the edge of the trench should be painted as an RGB hexadecimal color code. This can be completely ignored for the first part. When viewed from above, the example dig plan would result in the following loop of trench, hashmark, having been dug out from otherwise ground level terrain, dot. At this point, the trench could contain 38 cubic meters of lava. However, this is just an edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well. The lagoon can contain much more respectable 62 cubic meters of lava. In other words, the digger digs the trench and then the interior. The result is the number of cube holes the trench is made of, plus the number of cube holes needed to excavate the interior. The number of cube holes that the trench is made of can be easily obtained. We just sum the lengths of trench edges. We can make an observation that the trench is a polygon with integer vertex coordinates. There is a useful theorem for such a polygon called Pick's theorem. Let I be the number of integer points interior to the polygon, and let B be the number of integer points on its boundary, including both vertices and points along the sides. Then the area A of this polygon is A equals I plus B divided by 2 minus 1. You might ask, why are you showing me this? We can use this formula to calculate the number of interior points if we know the number of boundary points and the area. We already know how to calculate the number of boundary points. We just need to find a way how to calculate a polygon's area. Here the shoelace formula comes in handy. It is a mathematical algorithm to determine the area of a simple polygon whose vertices are described by their Cartesian coordinates in the plane. One way of calculating the area is using a triangle formula. A equals 1/2 of a sum xi times yi plus 1 minus xi plus 1 times yi. Now we have all the ingredients to solve this puzzle. First, I define a map of directions so I can calculate the vertices of the trench. Then I read the dig plan. Start at 0, 0 and follow the instructions in the plan. I get a perimeter, the number of boundary points, and a polygon represented as a list of points. Finally, I plug into the equation I derived from the Pick's theorem. In the second part, we are solving the same problem, but the lagoon is much larger. The color is 6 hexadecimal digits long. The first 5 hexadecimal digits encode the distance in meters as a 5-digit hexadecimal number. The last hexadecimal digit encodes the direction to dig. 0 means right, 1 means down, 2 means left, and 3 means up. The code is basically identical to the code from the first part. If you like this video and would like to see more like it, please subscribe. Thank you.